All right, it's on. Okay, so today we're going to talk about PieceWise functions. Okay? So you are supposed to have a pencil and a large eraser. All right? Everybody got it? Okay. So the first thing I want you to do, this is PieceWise. This kind of piece, not like piece man, all right, but PieceWise functions, because they are different pieces of functions. So I want you to draw a coordinate plane. I'm fixing to. Go ahead. Okay, so draw you a coordinate plane, an x and y axis, okay? And this is what a piecewise function is going to look like, okay? All right, so f of x is equal to, I do mine in a brace, okay? Because, and I only put a brace on the left. A lot of books do that. Some books do not do that. That's the way I was taught. And to me, it says that they all go together, so that's the way I do it. The first equation is the absolute value of x plus 2 minus 3, comma, x is less than or equal to, no, just less than, not or equal to, just less than, sorry. Less than 1, negative 1. All right, the second equation, negative 2, comma, when x is greater than or equal to negative 1, less than 2. And then 2x minus 3, comma, x is greater than or equal to 2. Okay, so here's what I'm going to say. If you don't know how to graph, you're going to be in trouble. This test is going to have 3 skills on it. One of them is regressions. That's the worksheet that you already have that you've probably been working on. We're going to take those 2 pages out that you have those stuff worked on, and we're going to pull them out of that worksheet and staple them on the back of the worksheet that I'm going to give you today. Today I'm teaching you piecewise functions. I will leave you with one to work on at home, and then tomorrow when you come to class, you can work on your worksheet. That way if you have questions, you can ask me questions, okay? You'll only have 20 minutes, all right? Because we only have 20 minutes of class tomorrow. Woohoo! And then Monday, I'll teach you the last skill, which will be transformations. You should already know all that stuff, but I'm going to teach it to you, okay? When I start teaching it, you're going to be like, oh, we already know this. I'm like, yes, you do, all right? So 3 skills. If you don't know how to do one of the skills, what are you going to make on the test? A 67. That's an F. That's if you do the other 2 skills perfectly. Do you understand what I'm saying? Yep. You have to know how to do all 3 of these skills. All right, so here we go. So take your pencil now, and we're going to graph this guy right here. Okay? So this is an absolute value function. When you graph it, first of all, how many points do I need? 3. Okay? So think if you were that one of those people that only said, no, I think I'll just put 1 on here instead. Okay? So, all right, so what does an absolute value function make when you graph it? A V. Okay, does this V open up or down? How do you know?
Positive.
What's positive? Yeah, but where is it? In front. Okay, it's in front of the absolute value out here. And there's not a negative sign, so that's why we know it opens up. What number is out here? Because I don't see a number. 1. Okay, just like if I wrote B, and I said, hey, how many B's is this? It's 1 B, right? I mean, I don't have to write the 1. It's understood to be a 1. If it was anything other than a 1, you had to write it. It's the same way here. So let's do this. This guy in here, this plus 2, what does this do to my B? Very good. If he's with an X, he is an X, and he moves left and right, opposite of what you think. So he goes left 2. All right, so he's right here. This minus 3, down 3. He's not with an X, guys, so he has to be a Y, and they move up and down just like you think. So 1, 2, 3. So this is the V of the absolute value function. You said my slope was positive 1, so I'm going to go up 1 and over 1. And then up 1 and to the left 1. Now, is that enough points to make my V? Okay, so lightly, did you hear that word? Lightly draw your V. Okay, now this graph has some constraints on it. Constraints are just restrictions. We have constraints to get in this class. In order to get in an Algebra 2 class, you have to have passed Algebra 1. Okay? So this equation right here has some constraints. There's his constraints. He only exists where the x's are what? Less than negative 1. You see, here's x's negative 1, so less than would be to the left. So erase everything to the right of negative 1. And erase that point at negative 1. We're going to talk about him. All right, is everybody okay so far? Yeah. Okay, so now this point right here, let's talk about it. Is it a solid, looking right here, is it a solid point or a hollow point?
Hollow.
Because why? Yeah, it's not or equal to, so this is a hollow point. So there's my graph so far. Are you with me? Okay. Now, this guy right here. What? What's this? What's this? Y. Y equals negative 2. People, if you don't know what kind of line that is, you might need to go talk to the counselor. All right? What kind of line is that? It's a what? It's a horizontal line. At negative 2. At negative 2. Okay, so draw us a horizontal line at negative 2. Draw it lightly. All right, everybody got it? Okay, now where does this line have some constraints?
Yeah.
Where does he exist?
Negative 1 and 2.
Between negative 1 and 2, where x's are greater than or equal to negative 1, but less than 2. Okay, so I'm going to erase everything to the left of negative 1, because he has to be greater than or equal to negative 1. And he has to be less than 2, so I'll erase everything to the right of 2. Now, we do have to address those point things, okay? We have to address. So let's look at this guy first. All right, he is right here on top of this hollow dot. So that's at negative 1. See, here x is negative 1. I'm right here. Okay, so what kind of dot should I have?
Closed.
Yeah, a solid dot. A solid dot on top of a hollow dot what does it look like? Yeah, just like a solid dot. People, it does not look like this.
Watch you.
Okay, it does not look like a scary eye. All right, don't do that. It's just a solid dot on top of a hollow dot, and it just makes a solid dot. All right. Now, what about this guy over here? He's at 2.
Hollow.
He's a hollow dot. Okay. Now let's graph this line right here. What's my slope?
2.
What's my y-intercept? Negative 3. So I'm going to go down to negative 3. 1, 2, 3. Make a dot on the lightly. My slope is 2, so I'm going to go up 2 and over 1 lightly. Up 2 and over 1 lightly. Lightly draw my line. Now, where does this line exist?
Greater than or equal to 2.
Greater than or equal to 2. So I'm starting at 2, and he only goes this way. Do you agree? Okay, so I need to erase all this mess down here. Do y'all like that?
No.
Me neither, so I'm going to show you a better way.
I'm having fun.
But you wouldn't have appreciated my better way if you hadn't done this way.
So you erase the point.
Okay? Now, I'm going to, what about this point right here? What's he supposed to be?
A solid
A
one.
solid point. Now, listen, guys, if this was a solid point and this was a solid point, would this still be a function? if this had been a solid point, and this had been a solid point, would that have been a function?
No, it doesn't pass the road.
Yeah, y'all, if you ran the vertical line, if both of these were solid, and you ran that vertical line test, as soon as you hit that point, you'd be like, oh, you're not a function, okay? This x would have two y's, one up here and one down here. So one being solid and one being hollow means there's only one y to that x. You understand? And this is a function. It's written as f is a function of x. Y is a function of x. All right, so now, do you want me to show you how I do it?
Yes.
Okay, so I'm going to show you how I do it. Now listen to me. Can you always go back to do it this way? People, like if you get stumped on the test and you go, you know how that happens sometimes? You go back to right here and you get your eraser out and you just start graphing and erasing. Okay? Where does this line exist? Where the x's are less than -1, so to the left of -1. Where does this line exist? In between these two, including the -1 but not including the 2. Where does this line exist? Just to the right of 2 and including 2. Okay? Are you with me? Alright, so I'm going to do the same problem, but I'm going to do it my way. Alright, so I'm going to go down here. I'm going to draw me a little graph. And I'm going to graph that same equation. F of x is equal to absolute value of x plus 2 minus 3 when x is less than -1, -2 when x is between -1 and 2, including -1, excluding 2, 2x minus 3 when x is greater than or equal to 2. Okay, so this is the first thing that I do. This has 3 different parts, right? How many lines will make 3 different parts on this coordinate plane?
3.
2. 2 lines. 2 vertical lines will separate this coordinate plane into 3 parts. Do you agree with that? Y'all, 1 line separates it into 2 parts. Okay? If I drew 1 line here, I'd have to the left of the line and to the right of the line. Alright? So I need 2 lines. These numbers right here tell me where those lines go. Okay? So I'm going to take a highlighter and I'm going to make dotted lines at -1 and at 2. Now, you don't have to do these lines, but these lines say, hey, Billy Gay, when you get to this line, you better stop. Because something different is going to happen on the other side. Okay? So, you're going to have one graph over here, one graph in the middle, and one graph over here. Alright? Those graphs never go outside their boundaries. This is someone's yard and nobody else comes in it. This is somebody else's yard, nobody else comes in it. This is somebody else's yard. No trespassing. Stay in your lane, however you want to say it, people. Okay? So the first thing I do is I'm going to start with that first equation, and I'm going to say, where do you go? Now you need to be really careful about this because I promise you, on the worksheet and the test, they're going to mix these things up and they're not going to go like in a logical order. For instance, when I first look at this, my brain wants to put this guy on the left, and this guy in the middle, and this guy on the right. But I need to make sure that's where he goes. This function right here takes place where x is less than -1. That's over here. Do you agree? So I'll write him over here. Y is equal to the absolute value of x plus 2 minus 3. Okay? Now I'm going to graph him. So he's an absolute value function, so he's a v. He's opening up because it's a positive absolute value. His slope is 1 because there's not a number out front. So I start at the origin. What does this plus 2 do to the v?
Left 2.
Left 2. 1, 2. What does the minus 3 do to the v? Down 3. 1, 2, 3. So there's the point of the v. The slope is 1. Are y'all with me? Tell me if I go too fast. The slope is 1, so I'm going to go up 1 and to the right 1. Oh, dang. I'm on that dotted line. I need to look over here and see what kind of point I want. It's either solid or hollow. Okay? So what is he? Hollow. He's an open dot. He does not have an or equal to. So I'll make him an open dot. Alright? Then I'll go up 1 and to the left 1. Now listen, some kids think that if this is a hollow dot, that all of these dots are hollow. Guys, this function exists where? To the left of -1. Why is this a hollow dot? Because it doesn't exist at -1, but only to the left. Do you understand what I'm saying? So this goes here, and then he goes up here, and what do I put on the end of this line?
An arrow.
An arrow, because he does keep going. All right, you with me? Okay, so this guy right here, he is in a horizontal line at -2, so he's right here. He goes from -1 inclusive to +2, so he's -2 in this middle section. Now I gotta decide what kind of points I want. At the -1, that's right here. Solid or open? Solid. So a solid point on top of an open point is just a big fat point. Solid point. Okay? What is he over here at 2? Open point. So this is y is equal to 2, -2. This line right here, he goes in this section. Y is equal to 2x minus 3. What's my slope? 2. My y-intercept is -3. I don't normally write that because I don't do it that way, but I'm going to show you how I do it. But I'm going to show you this way first. Some kids like to do it like this. Some kids go, okay, I'm going to graph it like I know to graph it, but I can't write until I get to this line. Do you understand what I'm saying?
Yes, I
Okay, so I'm going to start at -3. 1, 2, 3. Can I make that dot?
You can. You have to
Yeah,
erase it.
yeah, you'd have to erase it, people. You're not in your yard. This is his yard over here. Okay? So you can't make it. So they go down here and then they use their slope. Up 2 and over 1. Can I make a dot yet?
No.
I'm not in my yard. Up 2 and over 1. I can start right there. Do you agree? Okay, now this is the way I do it. I don't want to count all that mess, okay? So I just say, hey, where do you want to start? People, I want to start on this line, and that is this number that goes with that equation. Do you understand that? They're telling you what number to plug in for x. So, where x is 2, plug it in your equation, people. Find y. Y is 2 times 2 minus 3, okay? 2 times 2 minus 3. What's 2 times 2?
4,
What's 4 minus 3?
1.
So, this point is 2, 1. Is it an open circle or a solid circle? A solid circle. Now I can just use my slope. I go up 2 and over 1. Up 2 and over 1. And I draw my line, put an arrow on the end of it. Okay? So 2 different ways of working a problem. I don't care which way. If you like all those crumbly eraser things all over your desk and your bridges, then erase away. Okay? If you don't like that and you like this way, then do this way. But know this, when I'm grading this, I'm looking at these points right here. Do you understand? Your points on these breaking, where this function is divided, I'm looking at those. If they're wrong, I'll circle them, put -1 every time they're wrong. Okay? All right, you ready? Okay, so now we're going to do some weirdo problems. And then we're going to come back and do some more graphs, okay? But before we do any more graphs, I want to show you a problem. Because this is like this is a present on a test or a worksheet. F of x is equal to, this is your PieceWise function, -3x minus 4 when x is less than or equal to -2. 5 when x is greater than -2 and less than 1. 2 times the absolute value of x plus 3 minus 1 when x is greater than or equal to 1. Okay, so here's my first question. Is this a function? It says it is, right? It says y is a function of x, so it must be a function. They told me it's a function, okay? So, what's f of 0? Now, if this is a function, 0 is an x, right? How many answers, how many y's will this x have? 1.
plug in?
Where do I plug it in?
Every single X.
Every X you get.
If you plugged it in every X, how many answers would you get?
A whole bunch.
3,
So all the numbers?
3. So, does it have 3 answers?
No.
No, it's a function, people. It only has 1 answer. So how do I know where to plug it in?
I don't know.
Look at your constraints.
Your what?
Look at your restrictions.
Version.
Oh, your restriction is 0, so you can't.
That's not your restriction. Where are your restrictions, guys?
On the right.
On the right.
You just make sure they're all true? Oh, no.
Okay, let's think about this. Is this my X?
Yeah.
Okay, so X. Is 0 less than or equal to -2?
No.
No, so you're not going to use this equation, are you? You see what I'm saying? Is 0 between -2 and 1?
Yes.
So what's f of 0? There you go.
Oh.
Is 0 greater than 1? No, so you can't use this guy. Do you see how you're picking who you use? Eric, are you with me? You better wake up. All right, here we go. F of -4. Go. You find it.
What?
Oh my
F of -4. Where does he fit in, guys? Where does he fit in?
Negative 3x minus 4.
Yeah.
Would you?
So plug him in there.
Plug it in.
Is it 8?
That's exactly, yes.
Okay.
Yeah.
Look at the inequality if it's true.
No, you have to look at the inequality and see which one he satisfies. Okay? -4. Is he less than or equal to -2? Then that's the equation I have to use. Is he between -2 and 1?
No.
You can't use that equation. This is only for the x's that are between -2 and 1.
What are we?
Is he greater than or equal to 1? No, you can't use this equation. Why? Because he's only for the x's that are greater than or equal to 1. Okay? So, -4. Does he fit in 1, 2, or 3?
1.
So 3 times -3 times -4 minus 4. What's -3 times -4? 12 minus 4?
8.
Are you okay?
Sure.
All right, one more.
Oh, that's what you meant. I was like, what more what? It's the last one. Boom.
Is it 7?
Okay, you got it?
No.
No?
Yeah, I got it.
Okay, so 1. Y'all, you gotta figure out where he is. Is 1 less than or equal to -2? No. Is he between -2 and 1? No. He's close, right? But he isn't there. Is he greater than or equal to 1? He's equal to 1. So he's this guy right here. So 2 times the absolute value of x is 1 plus 3 minus 1. Y'all listen, you cannot distribute throughout an absolute value sign, okay? You have to solve inside it. What's 1 plus 3?
4.
What's the absolute value of 4?
4.
What's 4 times 2?
8.
And 8 minus 1?
7.
Perfect. Okay, so can you work problems like these?
Yep.
All right, those are pretty easy. All right, so let's go back to our graphing problems. All right, so here we go. Draw you another graph. We're going to do 2 graphs. I stole this out of my husband's truck this morning, or yesterday. But then he said I can't. I asked him this morning. After I took. Okay, I'm going to try to be tricky on this guy, okay? I'm going to be tricky on this one.
You were tricky about what?
Stop trying Sherman.
It's gonna take me a minute.
Okay, I'll give you 2 minutes.
Oh, no, that's all. That's not urgent.
Did you see the trick?
No,
How was that tricky?
I don't know.
Because they don't show the same one.
No? What about, where does this equation belong, on the left or the right?
Right?
Yeah, be careful, because your brain automatically looks at that first one and wants to put him over here. But this is where the x's are greater than 1, so I'll flip those, all right? That'll mess some kids up sometimes, all right? So be careful and look. Where does he go? He goes over here. Okay, where does he go? He goes over here, where the x's are less than or equal to 1. So, all right? So let's do him. My slope is 2 and my y-intercept is -1. Do you agree? Okay, so this should be pretty easy, right? He's right on my property, so I'm okay with this. Like, my y-intercept's -1. My slope is 2, so I go up 2 and over 1. Oh, I'm on the line, okay? So what kind of, look, I'm looking down here. What kind of dot do I have? Solid or open? Solid. Okay, if you need another point, you can go down and to the left. All right, now one thing that I kind of encourage you to check is maybe to check your slopes and be very careful, especially if you have a negative slope. All right, if you have a negative slope, remember those are the most difficult kind. Those are the kinds kids miss a lot. So this is a positive slope. Is this a positive slope?
I mean, no, it's going down.
Okay, so there's what kids do. They look at it and they go, no, that's not a positive slope because it's going down. But how do we read a line from left to right? And when you read it from left to right, is it going up?
Yes.
Yes, so that is a positive slope. When you put an arrow on it down here, it makes kids think it's going down. Okay, but when we read from left to right, it really goes up. All right, this guy over here, his slope is 3 and his y-intercept is 1. Are you with me? Okay, y'all look, you can't use his y-intercept. So you either use it and you figure out how to do it, or slap your little T-chart on there. What number? How do I know what to put in for x?
How do you get anything past 1?
Yeah, this guy right here, he's telling you what to put in for that x. He's saying, I'm starting at 1, lady, okay? You need to know what that is. So put a 1 in right here. 3 times 1 plus 1. 3 times 1 is 3, plus 1 is 4. So at 1, he's 4. Is it a solid dot or an open dot? open. 1, 2, 3, 4. And then I'm just gonna use my slope. Up 3, 1, 2, 3, and over 1.
Oh, so the second dot can be a closed dot?
Yes. Remember how, look, where does this line exist? To the right of 1, not on 1, that's why that's an open dot, but everything to the right of 1 is this line.
Oh, so it can be a function.
Yes. Okay? All right, you ready for one more?
Sure.
All right, here's another one. Oh, sorry. Yes? Absolute value. Opens up with slope 2, right 3, up 3. That's what that says, guys. Okay? So start from the origin. Do not start on that line. That is not a y-axis. Okay? So start at the origin. Go right 3, 1, 2, 3, up 3, 1, 2, 3. So here's my V. My slope is 2, so I go up 2 and over 1, up 2 and to the left 1. Do I have to do it again?
Yeah.
Yes, on the left-hand side you do, because I said I want to see that point over here. So, up 2 and here, this is the point. Is he solid or open? Solid. Okay, so down and an arrow on the right. All right, anybody got a question? No? Okay, one more thing, all right? Look at this right here. that a V? Y'all, that is not an absolute value function. Do you understand? Don't look at everything that's a V and go, oh, that's absolute value function. You can't, the slope of each side has to be the same. The slope of this side is a 1, but the slope of this side is a 3. Okay? So be careful with that. If you were doing that and that happened, I would know that there was a division line right in the middle of that. Do you understand? Okay? So you'd have to be writing the equation of this line and this line. All right. So the next thing I want you to do is, I drew one. This is how you find out if you really know what's going on. I drew one, and I want you to write the equation of it. Okay? So here it is, right here. So draw that on your paper, and you write the equation.
Does it matter what order we put the equations in?
No, normally we go from left to right, but sometimes they'll switch the order up just to see if kids know what they're doing.
Do you want us to draw that on our notes?
Mm-hmm.
The graph?
Yes?
Oh. Oh, no.
Just so you have something to go back and look at.
We have the video to look at.
What?
We have the video.
Excuse me, Miss Davis.
Yes, ma'am?
Did you send Serena to Johnny to the front office? She's leaving.
Yes, ma'am.
Thank you.
Thank you. When I'm writing the equation, what's the first thing you think I should do? What's the easiest thing to do?
The Y one?
Divide.
Oh.
See where my division lines are? You see what I'm saying? I mean, start off with something that's easy, guys. Please tell me you can decide where the division lines are in this graph. Yes? Where's the first one to the left?
-2.
Very good. Where's the one on the right?
3.
All right, one simple task, and now I'm like, oh, okay, I got a place to start. I'm gonna write the equation for this. Here's my y equals. It's an absolute value function, guys. Can you write the equation for this absolute value function?
Yeah.
Okay, so write it right there. I'll give you 20 seconds. Here's what I do know.
Okay, I got that one.
Now count his, what's his slope? 1, 2, 3, and over 1, over 1. So 3. Absolute value. How do you make him move to the left? 1, 2, 3 places. X plus 3. How do you make him move up? 1, 2, 3 places.
Wait, how'd you get the 3 again?
Because his slope's 3. Slope's 3 over 1. He moves to the left 3, so that's a plus 3. I shouldn't have put so many 3s in there. Yeah, and then plus 3 on the back. Where does this thing exist? Where the x's are what?
Less than -2.
Less than -2. Less than or equal to?
Oh, wait, no.
It's just
Okay, so that's my open dot. All right? Please tell me you can write the equation of this line. I mean, if this is the only one you can do, by golly, you better do it, people. Okay, what is it?
3.
3. Whew, that was hard. Are y'all okay? All right, where does he exist? From -2 to +3. So the x's greater than,
-2.
greater than or
Equal to.
equal to,
That's what I meant.
-2 and less than 3. All right, this one's not gonna be as easy, is it? You could take 2 points, right? Could use a point slope. Good night. Please tell me you can count the slope and tell what the slope is. Okay? I'm not going to do that. I'm going to cheat, and I'm going to keep using my slope and find out what my y-intercept is. You see what I'm saying? People, like, let's do it the easiest way we can. Do you agree I go up 2 and to the left 1 to get to that point? So I'm going to keep doing that. Up 2 and to the left 1. Up 2 and to the left 1. Up 2 and to the left 1. So there's my point right there. Okay? I mean, heck, if nothing else, you can't count, get your calculator and draw it, alright? It should be right there. So what is that? 1, 2, 3, 4, 5, 6, 7? So y is equal to, what's my slope? What kind of slope is that? It's negative. Negative what? 2x plus 7. Where does that exist? Where the x is greater than or equal to 3. Okay? Now, one little thing I want to make clear, and then we'll stop. Y'all listen to me. If I happen to put, I probably should have done that, but if I happen to have put one dot on top, a solid dot on top of a hollow dot, you have to include it in one place. You cannot include it in both of them. If you do, I'll take 2 points away from you. Do y'all understand what I mean? See this guy right here? Do you see this point? He's included in this V, or he is included in this line. He cannot be included in both places. You could pick either one. It would be right to include it in the V, or to include it in this horizontal line, but you cannot include it in both. Now, do you know what I'm talking about?
Wait, so what?
So like if I was writing this guy right here, which was my original one. So this guy, he's an absolute value function, right? He opens up. His slope is 1. So 1 times the absolute value up. How do I move him left 2? How do I move him down 3? Now, that is where the x's are. See, here are my division lines are right here. Okay? So, that is where the x's are less than -1. Could I include that here? If I wanted to, I could. This one is -2, where the x's are greater than -1, but less than 2. Now, one of these is included. I don't care which one you do. But if you do both of them, I'm taking points away. Now, do you understand what I'm talking about? Okay? So, do you want to include it up here or down there? Down there? Okay. So, don't put it both places. It could be either one, but you can't put it both. And then this guy, let's see, down 2 and to the left, down 2 and to the left. So, -3. So, y is equal to, my slope is 2x minus 3, where x is greater than or equal to 2. Okay? All right. Good deal. Let me pass out your worksheet.